Hey everyone, welcome to today's Explainer. We are talking about a massive gap that we're finally bridging. On one side, you've got the lightning-fast, cutting-edge world of modern AI agents, and on the other, well, you have the incredibly stubborn, completely locked-down world of legacy government documents. It's a huge friction point, but today I am super excited to walk you through an ingenious tool called kordoc, which is literally tearing that wall down. So let's get right into it.
Now, kordoc wasn't just built in a vacuum by someone tinkering with code on a weekend. As its creator famously noted, it was forged in the fire of absolute document hell. It was actually built by a Korean civil servant who spent 7 years, yes, 7 years, battling proprietary HWP files across real government projects. So this is a tool born out of pure, unfiltered necessity. Which brings us to a really critical question. What actually happens when an advanced LLM, like Claude or GPT, hits one of these proprietary government documents? Well, historically, it's a hard stop, just a total roadblock. I mean, LLMs are brilliant at analyzing text, sure, but they cannot natively read an obscure binary format, or a complex borderless PDF table, or a massive multi-sheet Excel file without completely losing all of its structure. It is incredibly frustrating.
Section 1. The Legacy Document Wall.
Okay, let's dive into this and compare the workflows. In a standard setup, if you try to feed a Korean government HWP file to an AI, it flat out fails. No way around it. If you feed it a complex PDF, the AI usually hallucinates or completely jumbles the table structures. You just lose the layout. But with kordoc wired into an AI via the Model Context Protocol, all that friction just disappears. The AI reads everything natively as clean, highly structured Markdown. It's like night and day.
Section 2. The kordoc Solution. To really understand the scale of this achievement, let's geek out on the deep architecture for a second. Legacy HWP 5.x relies on OLE2 and CFB containers. You can think of them as old, incredibly complex digital filing cabinets, kind of like ancient Microsoft Office files. The newer HWPX, on the other hand, uses zip and XML DOM. This wildly complex, varied architecture is exactly why your standard text editors just fail to open them. Kordoc's custom parsing engine is honestly a technical marvel, because it navigates these labyrinthine file structures completely natively.
And it doesn't just stop at one format. kordoc flawlessly converts a massive array of files. We're talking legacy HW, modern HWPX, and XML-based HWPML. But it also totally dominates standard Office formats, handling PDFs, multi-sheet Excel files, and Word documents. Basically, it brings both the highly unique Korean document ecosystem and global Office standards under one roof, instantly rendering the whole shebang into AI-ready Markdown.
Section 3. Wiring the MCP server.
So, to build this automated workflow, we rely on the Model Context Protocol, or MCP. If you haven't heard of it, it's an open standard that gives AI models secure superpowers to connect to external tools and data sources. Think of it like giving Claude Code a pair of hands to actually open files on your local computer, read them, and then seamlessly report back to you right in the chat.
And getting this running? Brilliantly simple. It literally takes about 30 seconds. You just need Node.js 18 or higher installed. You run a single command in your command line interface, npx-y kordoc setup. That's it. An interactive wizard pops up, detects if you're using Claude Code, Cursor, or Windsurf, and it automatically patches your configuration files. No manual JSON editing required at all. And if you're on Windows, it even wraps the commands automatically for you. Just like that, your AI is fully connected.
Section 4. The 8 AI Tools.
Now, what's really interesting here is watching how Claude Code independently chooses these tools mid-session. You can literally just drop a file path into your chat and say, hey, analyze this. The AI will internally trigger the Parse document tool to get clean Markdown. Or if you ask what changed between an old HW file and a new HWX file, it automatically uses compared documents to generate a red line diff, even across formats. Need a specific table? It uses parse table. Just need metadata? Parse metadata. The AI actually becomes the active operator of these tools.
Section 5. Deep Document Architecture.
Out in the real world, things get messy, right? But kordoc conquers the absolute toughest edge cases. Have a PDF table with absolutely no visible borders? kordoc actually rebuilds it using advanced cluster-based X-coordinate detection. Need to read a DRM-locked government file? Well, on Windows, kordoc automatically falls back to a COM API to extract the text page by page. It even handles complex merged tables with crazy col spans and row spans by outputting them as flawless HTML instead of Markdown, so literally zero structure is lost. Oh, and my favorite, it intelligently turns an empty square checkbox into a checked one when autofilling forms. How cool is that? And this leads us to what might just be the absolute most powerful feature of the whole system: full round-trip generation. See, this isn't just about reading data. It is about writing it. You can have your AI read a document, analyze it, draft a response, and then kordoc will reverse convert that markdown right back into a perfectly formatted, official HWPX file. It preserves the fonts, the sizes, the alignment. It completely removes the human copy-paste bottleneck.
Section 6. Legacy meets future AI.
Of course, processing unknown documents is inherently risky, but kordoc is built for real production environments and natively guards against malicious exploits. It prevents XXE attacks. Those are often called billion laughs attacks that try to crash your system. It blocks dangerous SSRF web redirects and symlink traversal when you're running in watch mode. And it even guards against CFB decompression bombs that try to overload your memory. It is seriously hardened for enterprise use.
So, what does this all mean? Ultimately, kordoc transforms what used to be an impenetrable document hell of proprietary lockdown government formats into a fully structured, automated playground for AI agents. It completely bridges the gap between legacy systems and modern LLM workflows.
Which leaves us with a final, pretty provocative question to chew on. If an AI can now seamlessly read, analyze, and even write the world's most stubborn, isolated proprietary formats using tools like kordoc and MCL, what massive, locked-away legacy system will we unlock next? I mean, the bottleneck isn't the AI anymore. It's just building the right bridge. Thanks so much for joining me on this explainer. Keep learning, and I'll catch you next time.